Hello one and all, in this one let's take a look at normalizing a function, in other words making it into a PDF. So we are given here that f of x, for example, equals c times x and then 0 otherwise. So in this context, for example, imagine that c times x is defined when 0 is less than x, which is less than or equal to 1. And then the value is 0 OW, which means otherwise. So our goal is to take cx and make it into a PDF by finding the value of c that will ensure that the area under c times x is equal to 1. That's our goal here. So we can integrate. In other words, I'm going to integrate here from 0 to 1 and then c times x, and this has to be equal to 1. That's the definition of normalization essentially. So then you just factor that c out, just the way I did. Now we have 0 to 1 x dx equals 1. This is an equation, so you integrate it and you just solve for the value of c. So when I do that, I'm going to have the following c. Now this integrated will give you 1/2 x squared between 1 and 0 is equal to 1 still. Let's plug in the upper lower limits of integration. So it's going to give us now c multiplying 1/2 and then 1 squared minus 1/2 0 squared, and this is still equal to 1. Let's continue. So c, and now this is going to give you just 1/2. The negative 1/2 0 squared, that portion is just 0, so this basically goes away. So now this is going to just leave us basically 1/2 equals to 1, and then you just multiply by 2 to solve for c. So c equals 2. So this is the value of c that normalizes our function. So now I can rewrite the function as follows. So I'm rewriting it up top. I'm going to have f of x equals 2x, and this is between 0 and 1, and then 0 otherwise. And what this 2 that we have found here means is that now the area under 2x between 0 and 1 is equal to 1. That's what makes it a PDF. So we begin with just cx, where c is a parameter, we don't know its value. And by applying these steps of integration, we have turned it into 2x, and now we can be sure that if I find the area under 2x between 0 and 1 over here, that our area will be equal to 1. So it makes it a PDF. So I'm going to make an x-axis this way, and I'm going to make a y-axis this way. So let's call this x, let's call this baby y, and then here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can make this a 1. That's all you really need. And now take a look over here. When x has the value 1 and you plug it in here, you would have 2 times 1, which is 2. So that has to go up to 2. I won't fit it obviously, so I'm just going to make it, have a different scale. So for example, say 1, 2, 3, 4. Let's say this is a 2 in this context. Then these things, roughly speaking, meet at this point. And then what we have is a triangular looking structure that looks like that. And here let's shade this a little bit, so it's this area that is equal to 1 under the graph. Alright, thanks so much for watching. Please leave a like and subscribe. I'll see you in another video.